Alright, so this is just an intro video to programming offline with Zeiss Calypso software. We're using 2021 version, which is the one we run at the college on most of the CMMs there. So this is what it's going to look like once you open up Calypso on your offline seat. And basically it's a little bit different than what you're used to at the machines. We're going to create a CMM connection because this software is the same for multiple different types of machines that Zeiss makes. So let's create a CMM connection. So notice that I have a machine built here, Duramax already. We'll build a new one, okay? So we have some options here. We can go to measuring system, okay? And then what I usually do is just go in here and I'll do Duramax 2, let's say. Then select rename, add, and notice Duramax 2 is now sort of on this tab here. So now we can go up to the machine, select the Duramax from the list, okay, and I go to default. This machine has a 500mm square measuring area. We can then go down to the probe. It's going to be a Zeiss fixed mounting XXT probe system. That's fine. Hit apply. And then everything else in here should be fine. Okay, if it isn't, we can change it later. Alright, but we just created a new machine. You get multiple machines here. So remember, it's going to be simulation offline only. That should not be an option here. Zeiss 32-bit by default. We will connect right now. And it should prompt us that a master probe has been created. Yep, that's perfect. Hit OK. And notice our traffic light appears. And then usually I'll minimize that and hit OK. Alright. And here we go. This should look more familiar. Okay. So once you get that done, I'll put a little transition here, and then we can continue getting our styli set up. Alright, so let's take a look at creating a new measurement plan and take care of our styli. So just do new measurement plan. And then let's focus over on this Stylus system. So just like you would at the machine tool, we need to do all the calibrations, except for nothing's actually going to happen. So right now, we just need to do a reference sphere position. All of this is irrelevant. Hit OK, OK. And we get a green check, we're good to go. The master probe is all set. As far as automatic tool changes, it's not a bad idea. You could set up a changer and define holder locations and all that. I don't think it's worth it for this one, so we'll just leave it because that'll come in at the machine. So I wouldn't worry about that. So the master probe's set here, so just hit OK. Alright, so that's done. Again, this is not like machines that have separate controllers. This is the controller per se of the machine. It's not like running a Haas CNC or something like that. So now we can go into the planner and we can go to import an SSC file, which is your Stylus system. Now there is one provided for you on Blackboard. You can load that. I'm going to end up going to load system, and I have it saved on my desktop. So HVCC 3x38, hit open, and then accept loaded system. And then this comes up, which you should be familiar with. Okay, 3x38, Z down, and Stylus number 1. That's fine. Hit OK. Close. Notice the Stylus system is now loaded. Okay. What we can do now is click and qualify Stylus like you would at the machine. Just hit qualify Stylus. Everything's okay through here. It's done. This is all set. The only difference is we need to take care of the length because we didn't actually calibrate. It doesn't actually know where the end of the styli is. So that means we need to go into our manager and we need to double check our geometry. Okay, so provided on Blackboard is a Zeiss report output. Let me see, it's called, what do I save it as? It looks like HVCC 3x38 info. What I have on my desktop, it should look like this, and at all this printout, the only thing we're really focused on is down here. Okay, so the Z position down is negative 58.339 millimeters, which converts to negative 2.2968 millimeters. Okay, so that's what we have to type in here. So if we go back to Calypso, we need to get into here or go into this dialog box here, but either way, Style System Manager, Geometry, and in the Z geometry, negative 2.2968. Now, The next thing we got to watch out for is our vectors. Make sure it is 0, 0, 1, which makes it a Z down. And after that, we should be in good shape. So I'm just going to apply and close. Okay? Then hit OK. So that should take care of that stylus system. Now, if you have problems, if for whatever reason the Z is going down too far, that is where usually the error occurs, in the height of that. So we'll leave that for now. And then I'll end up putting a transition here, let you keep up. Again, in the manager, make sure you end up typing in the negative 2.2968 value, and make sure the vector is 0, 0, 1 for the geometry of this stylus. Okay, hit close, and I'll transition here and we'll continue. Alright, so now that we have our machine set up and our stylus system set up that we're going to use for this program, we can import our CAD model. So on Blackboard there's one provided, so just go to CAD file, load, and then I'm going to end up going to my desktop and make sure you search for a step file, and it's mill part 1, and hit open. Make sure it's a step file in this dialog. Okay, hit open. And our file loads. Now it's going to come in wireframe, but down at the bottom here you can select solid. Okay, and there's our CAD file. Okay, so the first thing we need to take care of is going to be our alignment. Okay, just like you would on the regular machine, right? You know, what the walk up and measure method. So first thing we need to do, and some people might critique here, there are options to, you know, clean up the CAD file, as far as automatic healing and things. This model is very simple, it's not worth it. There are options in here as far as different CAD functions, so like settings, colors, the part, you can change part settings, the color, geometry colors, whatever you like. There's a lot of different options here, like any other CAD or CAM system, but this is fine for us. Even the background, other colors you can change, but the Calypso, unlike Mastercam, if you're taking that class with me, this doesn't bother me. I'm kind of used to it. Where Mastercam, I prefer a darker background and whole, you know, workspace. But anyway, go to measurement, and what I'm going to do is go to base start alignment. Now, this system, I don't have any of my defaults on that I remember anyway. I had to turn them all off. So I'm trying to work with the same system you are at the machine. So keep that in mind. Now, there might be some automatic paths popping up here, there. We are going to scan this part just to add some more complexity to this versus taking individual points. We should be pretty familiar with that by now. So I'll go ahead and go to base start alignment, create a new one, that's fine. And then what I like to do is down the bottom here, this one's critical. Define select geometry. We're going to select the top plane. Okay, notice rotation space is the origin. It selected that. There's no strategy yet or anything because all my defaults are off. Let's just leave that. Let's take care of these two lines next. Okay, now this is different. Don't just select these because it's going to default to plane. These are a little bit unstable to create a plane on. So what we can do is go to define line on a plane, click and hold and drag over, and then click and hold and drag over, and that creates lines on the plane. Okay. Notice our 0, 0 is in the correct spot. It's up to you which one is aligned. This is a pretty simple part. There's no crazy geometry or geometric tolerance or anything, so this is fine for us. So we'll hit OK. So notice our part is now aligned. Okay. So now what we can do is we can go to clearance plane. Okay, and one thing is we are probably in metric by default, so let's fix that now. Let's go into CMM, or measurement, sorry. Measurement plan editor features, units, length unit, inch. Hit OK. Now we go to clearance plane. Clearance plane. Instead of taking points now, we're going to go clearance plane from CAD model. Let's do a distance of, let's say, an inch. Hit OK. I get rid of the Z minus, and then hit OK. So now our clearance plane is taken care of very quickly. All right. So right now we are ready to start running the program. Okay. So a couple different ways to do that. All right. You can just right-click, like let's say the line. The line has information. There's already a strategy in there. We'll talk about that in a minute. But you can just right-click and execute, and it will actually execute it. But nothing. You don't see anything happen. There's no simulation, right? So that's where you got to go to Planner, Measurement Plan Simulation, and leave this open. Okay. Then if you right-click and execute, the stylus should come down, and now see we have an issue. Okay. what just happened, what I mentioned earlier. Notice if I rerun this, you hear a crash. So let's fix that. So let's go back into our, or we can enter right here, either way, our Stylus System Manager. And let's go to the geometry. And notice, since I changed from metric to inch, our numbers got kind of messed up. So let's fix that. Minus 2.2968. Okay, hit apply, and our vector's still good, and hit close. Okay, so now we can try going to the planner, measurement plan simulation, and when this is up, essentially, that's when you're going to be simulating. Go to features, right click, and execute. And notice it's much better. So again, you are probably going to run into that because your defaults are kind of the machine set defaults. They're not like my offline C different options for my save load defaults are all set. I took those all off for this, okay, and you will have the same thing, so that's something you're going to run into. So that's simulation. Let's transition here. We'll get into some of the strategies occurring here, and then we'll continue with that. Alright, so the 2D line by default should have a strategy like a line auto path. This is fine. I'm not worried about the number of points yet. I'm not worried about the speed or any of that. Let's just use default for now. All this stuff is defined by Zeiss in a what they call the cookbook. But for right now, let's just leave it alone. Let's one thing at a time. Let's just watch the machine scan. It'll be nice and slow. For this part, it's irrelevant. We'll focus on that later. So hit OK, and even the both 2D lines should be OK. So saying that, let's go into plane 1 and notice that there is no strategy. So let's look at some of the options we have. There's different ways to do this, okay, and one way to do this is you can actually just click and take points. Okay, something like that. Okay, then let's say you don't want to take points. You wanted to scan this path. You can select all of these probing points and do the auto path switch and make a polyline that way. Okay, and then you can get into here into the different sets of points, and you should be able to click and drag points around like that. And you can really control the path of where you want it to go. That's fine. You can hit OK here, and then if that doesn't work, you can hit delete. There's other options here. There's grid. There's polyline, which polyline is pretty easy. It's kind of like what we just did, except for it's automatic, because we'll do polyline for model and edge distance of like 1/8 of an inch. Hit OK, and there's a polyline. And you could do multiple strategies in this list. There's no reason you could have more than one. But sort of the go-to for a lot of people is multiple polyline with an edge distance of, let's say, I don't know, 0.060. Then you hit OK. And you'll see it's kind of automatic. Okay? The only problem for us is we can run into issues around the outside because of our clamping. Okay? There are some options. You can tweak that. You know, some of these you can click and drag around. So let's say you move this one in and then move this one in and your clamps are here or something like that. That could work. You know, there's a lot of options. Okay? Notice there's multiple polylines. But for us, since we want the most control possible, and we do have to get a flatness out of this, I am going to sort of guide this around. So, you know, here, I don't know, here to here, let's say. And we could do multiple scans. We don't have to necessarily, you know, if you hold shift, you just delete these. You know, there's no, you know, you can work with this as you want. Let's say our, you know, our clamps are here and here, let's say, up on the top. Okay, so we want to stay away from that area. So we can go here to here, here, to let's say here, here, to here, then over, then maybe up to here, then over, then here. And that'd be a pretty decent grasp on flatness. You know, we could take some more lines here. That's up to you. This part's not going to be flat. It is stock. So I'm not going to get too crazy in a scan path. If we were really trying to capture flatness, it would be a little different. But just for an intro video, this is fine. So we could just hit shift from the bottom here, select them all, turn it to a polyline, and you'll get the idea. Okay. As far as speed and all that, leave it by default. We're not going to cite the cookbook for this. Then again, we could always change these later, so we can hit OK. Now we have a strategy. Clearance status should be Z positive. That's good. We'll hit OK. And here's our alignment features. Okay, so one thing I like to do a lot of times is right-click and form a group, and then right-click, rename, and this will be alignment. Hit OK. And then what we can do is go to our planner, turn measurement plan simulation on. Okay, and sometimes I just park this out of the way. And then we can run our program. We're going to clear existing results. We're going to do measurement plan 4, use clearance plane, everything else should be okay. Hit start, and it should scan the workpiece. Okay, so that's it for that one. Okay, so our alignment is complete. All right, so it's a good time to save. So I'm going to go File, Save As. I'm just going to go right on my desktop, and this will just be example. And remember, this saves as a folder. So if you ever need to send this to me, or however I ask for these programs, it needs to be in a zipped folder or a compressed folder and emailed or uploaded that way. You do not ever separate the folders, although you will be opening the inspection as you've done in the past, but the folder has all the information you need. So remember, treat the folder as the program, and you'll stay in good shape that way. So there's our features, our alignment. We have no characteristics yet. Like I said earlier, we'll transition and let you catch up, and then we'll take care of actually measuring this workpiece. Alright, so let's take care of the holes for this one. So if you just use define select geometry, it will default to cylinders, and we're not trying to capture a positional tolerance as far as the GD&T spec, and this is a little bit unstable, so we're going to create circles. The other thing is, the way I'm going to have this spec'd out in the report is going to be hole 1, 2, 3, 4, 5, 6, 7, 8, and so on, and then it'll just be hole 1, X, Y, and diameter. So that's the way I'm going to program this, okay, as far as my characteristic listing. So what you want to do is go down to this box down here and go to define circle on a cylinder. Now, one thing to remember, the Z height in which you select this is where that circle is going to be. So here, here, and keep just going. And we could do a pattern here, but I think it's better to get some repetition. It's not that many holes. So we have our circles. Okay. So now we can output all the information we need. Okay. So for us, circle 1, we need to output the X, the Y, and the diameter. But before we do that, let's double check our strategy. It should be a circle path by default. This is perfect. Again, the cookbook settings, we would update this. Usually they go past 360. For us, that's okay. If you're worried about anything about this before you output the characteristic, you'd always just go to planner quick and right click and execute, and you'll see it comes in and takes care of the hole. One other thing I like to do is I like to go into measurement plan editor features and go into the Stylus system Stylus, and make sure that if you're Z down in the Stylus, that Z positive is your clearance plane for parts like this. So that's a good way to check to make sure your clearance planes are correct. So anyway, we have our features, circle 1, X, Y, and diameter. Now notice, the nominals are all there because they're from the model. Okay, the tolerances are not. All locations are plus or minus 5. The diameter tolerance is plus 10 minus 4. And the naming is fine for us. That works out well. I'm trying to think if there's anything else here. The Z we don't need to output. The Z minus 56 is fine. That's the where the Z is here. We might change that. It really doesn't matter unless we have a scan issue. So I'll probably leave that for now. If I have to transform that later, I will. There's options for evaluations. We're going to use least square feature. We'll talk about the filters and outliers. That's all cookbook type things with scanning. I think it's way out of the scope of just an intro video for now. So we're good here. Okay. Then hit OK. So now circle 1 is done and we have characteristics. Okay. So let's take care of the rest of these holes. Right? They're all coming from that gnomon. So if I minimize Calypso and take a look at mill part 1 drawing, they're all coming from lower left. Okay, we're all good there. So let's take care of that. Okay. So let's get back into Calypso. And then let's take care of all of these circles. All right, so we'll go to the paintbrush transfer format icon here while circle 1 is selected. We are going to translate the characteristics from circle 1 to every other circle. Okay, and then hit OK. Now you'll see we have all our characteristics done very quickly. Now, you could group these. It's not a bad idea. You could go through and, right click and form group. It makes the report a little nicer. So this can be rename, and this will be, circle 1 or hole 1, whatever you want it to be. And then I would continue down and do the same thing over and over again. I won't bore you with that, but again, I recommend that you do that because you'll see the difference on the report. Good time to save. And now all the holes are done. Let's actually watch this run in simulation, just to be sure we run okay. And then you can make this screen smaller. It doesn't need to be that big. And then we go to run. Make sure we go to our third example 1 alignment. Everything here, all characteristics, and hit start. And we should watch it do everything, the plane included. And the speed at which it simulates is up here. And I don't really use a lot of the other icons in here in the introductory videos showing the machine and stuff. It's not worth it. The other thing we could do is make sure that the stylight enters the hole at the center. I might post a quick formula on that, but for right now, you'll be okay for this part. So let's just take care of that. We won't worry about that for this one. We will later. If the stylight gets very, close to the size and diameter of the hole, or the hole tolerance is very large, it's a good idea to make sure that you'll see the grouping here. Sorry to break up here. It's a good idea if the styli is close to the size of the hole or the tolerance is very large, that you always enter to the center of the hole to avoid hitting. But for this part, you'll be fine. Anyway, here's our report. You'll see hole 1, how it groups it very nicely. So it is a good idea to group them like this in the characteristics. It'll just be easier to read in your report. Okay. So anyway, that worked out well. Everything's going to be green. Because it's nominal. There are ways to overwrite to get Calypso to kick out results, but for this part it's not worth it. So anyway, let's transition here. We'll take care of the lines, caliper distances, take a look at some reporting options, and finish this up. Alright, now that we're back, you'll see I grouped all of these circles, and then we can take care of our last few dimensions. So if we look at our drawing, we got to take care of the 3-inch widths. We got to take care of the 3/8 real quick, something we probably did not cover in class yet, and the flatness, which is no big deal. So let's take care of these widths. We need some new features for that, so we're going to go to define line on a plane and take care of this line, and then back here, this line. Okay, so there they are. Now we can do what's called a caliper distance, or you have a couple options here. You don't have to do caliper distance. If you do line 3 here, if you just go X, 3 inches plus or minus 20, that would work. Okay, there's nothing wrong with that. You treat them kind of like we did the circles. Or, again, you could go, if you're in characteristics, you can go into size, distance, caliper distance. And caliper is sort of the go-to because it's going to mimic, using conventional, measuring instruments like calipers. So it's going to be, end up being line 2. To line 3, and that's going to be in the X, 3 inches, and it should be plus or minus 20 thousandths. Okay, and this is fine. Caliper distance 1. This could be X dimension, X width, something like that. And again, if we bubbled the drawing, this could be whatever dimensions they are. That's what you'd match up to. That works for me. That's fine. Okay, but it doesn't matter. Hopefully, if we get into PyWeb later on, we can bring this drawing in, and I'll show you how to do that. But I'll address that when we get further into the class, hopefully. So anyway, we'll hit OK here. Let's do the same thing. We just do copy and paste here, just to show you another way to do this. And then we can go in here and change our features to line 1, and then line 4, and then change it to the y-axis, plus or minus 20, and hit, this will be y width, or height, whatever you want to do. Let's say height. That's fine, just an example. Hit OK. So there they are. Okay, we could actually run them here. So if we hold Shift and right click and execute both those now quickly, there they are. And then again, that's pretty much it for those, pretty simple. The last one that we might not have done in class, and actually second to last, we'll do flatness quick too, is this 3/8, okay, plus or minus 20, the thickness of the workpiece. So you can't really get that on our setup. If we were on the surface plate, on a machine that had a surface plate, you could just probe the plate itself. On our fixture plates, I don't think that's a great idea. But you can go, you have options. You go to size, more, and what's called result element. And this will just be, thickness. And the nominal is going to be 3/8 plus or minus 20. And then the result input will be measure just. Okay. So if you hit OK, right click and execute, this is what's going to happen in the program. Measure part thickness, type in the value, hit OK, and it goes into the report. So you can implement a manual measurement into your report pretty easily. Okay. Last one we'll just do quick is the flatness form location. Flatness. Flatness is going to be on plane 1. And the tolerance for that should be 2000s. Okay, and because these are stock, they're most likely going to be out of spec, but that's okay. Then hit OK. And then good time to save. Okay, so this part is done. Okay, we can quick open the planner up, and you can minimize that if you want, but I usually don't. We'll just go run it and start it again, let it run. And watch the program take care of everything. Make sure you don't have any weird collisions or anything. Again, we don't have fixturing loaded or anything. We can watch at the machine and fix it when we get there. But this takes care of a lot of programming pretty quick. And again, you could do this at the machine. You won't have this simulation like this necessarily. But you could actually program, and this simulation occurring could be the machine doing the work. So there's different options. So there it is. And you'll see I changed my PyWeb report to a Hudson Valley report. Okay, and I'll show you quickly the nice groupings here. I'll show you quickly how to do that, how to get this report in the right location on your computer. Okay, so I'll transition here, and we'll come back and I'll show you about that report, and that should be the end of this lesson. Okay, so you're not going to have the Hudson Valley, the report I created on your computer on offline seats. I did load them in the lab. So you got to go to multiple report first time you're doing this, and then what I would do is go to the 3 dots here, and then in the generic templates, or actually you're not going to have anything here like I do, so you're not going to have a folder created yet. So go to Zeiss templates, and you can just go to standard protocol. And if you go to select and then edit, it should prompt you to do unable to save it in Zeiss templates, because that's the basic Zeiss directory. We want to save it in generic templates. Okay, so just click that, and you'll see I have a list of things in here, and then you can just hit save. Now PyWeb's going to open, and that's fine. Okay, what I want you to do is just close out of it for now. We don't need that yet. I'll show you that later. What I want you to do now, though, is hit OK, and then download the hvcc.ptx folder that's on Blackboard. I want you to right-click this and copy it once you download it. Then right-click and get into File Explorer, and then go to C, Users, Public Documents, Zeiss, Calypso, Protocol, PyWeb Reporting Templates, and paste it. Now I already have it in there, but that's the folder. This is the file map where you want to paste that. Once that's there, you should be able to go to multi-report, go to generic templates, and you will have this template. Hit select. There it is. So now once that's in there, that's the report template that Calypso is going to populate. So hit this little icon here, and there's your report. You can type in the part name, part number, the instructor of the class, the CMM number you were using, the programmer, which is you, add a spec, time and date should be here. I can make that window bigger. I can show you that later, but I'm not worried about it for right now. And then the save as PDF. I know some people are having issues with this, but it does work now. Okay, and I can show you how to tweak that in class as well. But again, you'll see each page you report, nice and organized. All right, and that's it for this one. Okay, again, good time to save. And I think I hit on everything I wanted to. So hopefully that was a little bit easier than programming offline. Again, this, I think, programming with the CAD model is much easier, whether it's offline or at the machine. Either way, this very similar. Programming this at home is what I recommend. You'd be able to get it done and then run it in the class. And once we get kind of used to this, you'll be able to get twice the work done. Okay, so if you have any questions, definitely reach out by email or leave a comment below if you're not taking this class. But either way, if you have any questions, let me know. Thanks for watching.